Assalamualaikum, this is me Aisha Batul, 16D01. So this is our video for 11th week, and today we'll be discussing about the window method. From where the window method arises, it is because of the Gibbs effect. When there are high frequencies, that is fast transitions, ripples will be produced in the pass band and the stop band. So these oscillations will cause the Gibbs effect. In order to overcome this Gibbs effect, we basically use a windows method. So applying the window sequence to the filter coefficient, we get this following equation from n is basically from minus m to m, and hw of n is equals to h of n dot w of n, where h of n is the impulse response and w of n is the window response. So there are basically common common window functions, that is rectangular window, triangular window, Hamming window, and Hanning window, and similarly the Blackman window. So we'll discuss them one by one. Rectangular window, it's basically the rectangular window have the window response is equals to 1, and where n varies from minus m to m. Similarly, the triangular window is 1 minus mod of n over m, and similarly the n is lying from minus m to m. Then comes the Hamming window, we get 0.5 plus 0.5 cos n pi over m, and from the Hanning window we get 0.5 plus 0.46 cos pi of n over m. And for the Blackman window we get 0.42 plus 0.5 cos n pi over m plus 0.08 cos 2 n pi over m. From all the sequences we get n from minus m to m. The mostly common used windows are the Hamming and the Hanning window. These are the mostly used windows in our finite impulse response case, and in order to overcome the Gibbs effect, we basically use the windows method. So let us consider an example. Here we are given with the impulse responses h of 0 is equal to 0.25, h of 1 and h of 1 minus 1, because when we plot the response we get a symmetric pattern. So h of 1 and h of minus 1 are symmetric and they are equal. So 0.25508, it's a value given, and h of minus 2 and h of 2 is 0.15915, and h of minus 3 and h of 3 is given as 0.07503. So we have to apply the Hamming window. We are asked to apply a Hamming window. We know the length is given as n is equals to m plus 1. Here m is equals to 3, because total values that we are having here is 1, 2, 3, 4, 5, 6, 7. So when we plug in 7 here, we get m is equals to 3. Okay, now we will calculate the Hamming window for every value, that is 0, 1, minus 1, minus 2 and 2 and minus 3 and 3. So what we will do, we will plug in these value into the function of Hamming window. There is 0.5 plus 0.5 cos n pi over m. Here plug in instead of n we will put values like 0, 1, minus 1, minus 2, 2, minus 3 and 3, and we will get our values. So I have plugged in some values here and I have calculated their following results. As when we plug 0 here, I'll get 1. When I'll plug in 1 and minus 1, I'll get 0.77, and when I'll plug 2 and minus 2, I will be getting 0.31. When I'll plug minus 3 and 3, I'll be getting 0.08. So so in order to calculate the total window function, I will be multiplying the impulse responses given in the above equation with the window function that I have calculated here, and when you will multiply each function, you will get the final result. And I have not put here because I was not asked for this step. I just did it extra one. So up here it was a requirement of the question, and I hope so that it will be helpful for you. If there is any query, let me know in the comment section. Thank you so much.